Alright, so let's try to differentiate y is equal to the root of x from first principle in the simplest and fastest way possible. So we understand that the definition of a derivative from first principle is given by the limit as h approaches 0. You may use delta for that. Is so f x plus h minus function of x divided by h. Okay, so this is actually the derivative. So we can actually say y prime is equal to that from first principles. Now, functions shouldn't be something that are new to you. So when you say f of x plus h implies we have is x in the original function, which in this case we can say f of our x is the root of x. So if we are to say f of x plus h, that would imply where we have x, we're going to have x plus h. And so with that we can substitute in the equation. Okay, so the limit as h approaches 0, f of x plus h, we have the root of x plus h minus the root of x for f of x divided by h. Okay, so at this point, if it is possible for us to substitute h is equal to 0 or h approaches 0 directly in the given equation on our right, you can, but in this case we can't because h is actually the denominator, so we have to find a way that we can actually do away with it. Okay, so if you've done SADs, you understand that actually we can actually do something to a numerator so that we can actually end up with h. So multiplying by the conjugate, that implies changing the sign in between, so that would be the root of x plus h, and then change the sign in between. Okay, so do the same to the denominator as well. Alright, so from application of the conjugates, we understand that just multiply the like parts. So whenever you multiply a root by itself, this by that, a root of course represents half, so that is basically just going to give us the limit as h approaches 0, this first part multiplied by the other part, so that's going to be x plus h. Okay, so if you want me to demonstrate to you how that comes about, the root of x plus h multiplied by the root of x plus h, if you want you can actually use indices. The square root implies half. Okay, so maintain the x plus h and then add the powers since you are actually multiplying it twice, so that would just be 1. Okay, and then that would also apply to this, multiplied by that, it would just be minus x. Okay, so if we are to put these in brackets and then you are trying to understand how the middle part is eliminated, it's actually very simple. Okay, because if you multiply this part with the other part, it is going to be a positive root of x plus h, and then the second part will be minus of it when you multiply this with this, so that middle part is always eliminated, and that's why when you're multiplying the conjugate, we actually just multiply the like parts. And then for our denominator, we are still going to have h remaining multiplied by what is in the brackets, that is the root of x plus h plus the root of x. Okay, so from there, what are we seeing now? So we now end up with a limit as h approaches 0. You can actually remove this. So we can see that x minus x actually can subtract, so you just end up with h being the numerator, and then on the denominator we've got h, open the brackets, the root of x plus h plus the root of x, and then we know these can divide. That's 1, that's 1. So what are we remaining with? We're remaining with a limit as h approaches 0, 1 over the root of x plus h plus the root of x. Okay, at this point, the h that was on the denominator that we're trying to avoid because of a 0 that it would actually put on the denominator, we can divide by a 0, is actually dealt away with, and so we can just easily substitute the 0 where there is h. So you end up with the limit as h approaches 0, 1 over root of x plus 0 plus root of x. Forget about the limit. You end up with 1 over root of x plus root of x, and basically we understand what that is equal to. That is going to be 1. These are like terms, so 1 1, that will give us 2 root of x, and that is basically our answer. Okay, if you want, apply the power rule to ensure that you're confident of your answer. Square root is the same as the power half. So a power rule tells us to determine the derivative, multiply the coefficient by the power, which will be half, and then reduce the power by 1. So half minus 1 is going to be negative half. So you can actually take x to the denominator so that it becomes the positive power. Okay, that's how it's going to end up giving us 1 over 2 root of x.